Okay, hello, welcome back again. So today I'm working on a program. This is a dsP33F family. So I've written an interrupt routine program using timer one. So I have a function. I want to be reading ADC, take sample from my ADC and 40 samples in my ADC within 20 microseconds. So I want to know how long it takes for it to execute in real time. That's how long it takes for the microcontroller to run the loop 40 times and do the arithmetic. So already we are going to use the tool debugging circuit, debugger. So I enter into the debugging mode. So you can see here we have a watch clock. You can see here we have a watch clock and it starts from void main. So if I use this tool here to step into, this is step over. So if I click step over, it goes to the next instruction. So you can see that the change is 0.50 microseconds. It takes to run the other instruction. Another one, 1.30 microseconds. Then LCD init before the other line takes 1.40. So the same way, you see the LCD initialize takes 60.06 microseconds. So you can see it takes a lot of time, So you see LCD command, LCD cursor off. So you can see this. Then you have a 100 millisecond delay. So you can see here that the time is 71 microseconds. So if we step into that, and step over, you can see that the 1,000 microseconds has been executed. So now we have this. This is where we are interested in the while loop. So we want to see how long it takes for it to do this arithmetic and get to this particular point. So I'm going to place my cursor here. So, and if I step over, you see it goes to the end of the line. I step again, it comes back to the beginning. So you see, if process done is equal to 1, that is when this loop is going to execute. So what we are going to do is that we are going to change the value of the process done. You can see that the process done here, because our cursor is here, the process done here is 0. So I change the process done here to 1. So once I change it to 1, then I place my cursor here. I can now use this command to run to cursor. But first, I have to zero this, reset to 0. That we are interested in the delta because that's the time it takes to run this loop into 40. We want to do the ADC sampling 40 times. So what I'm going to do, I'm going to click this. So you see, it has run the simulation. So you can see here that we have 220 microseconds. So it takes the dsP33F 220 microseconds to run this ADC 40 times because we want to do ADC sampling. We want to sample, we want to read the value we get from the sample, then use it to get the square of each of the value. After getting square of each of the value, we find the mean of the squares, that's divided by 40, then we find the square root. So after performing all this arithmetic, then this is the scaling factor. We want to scale it so that it can show the right value on the LCD screen. So you can see with this, we can actually know the number of time it takes for it to run this. So when you are writing program, it's good to know how long or the instruction cycles that you're going to execute. So because DSP is very hard to simulate. So but using this debugging tool, we can actually know how long it takes to run certain routines in our program. Thank you once more. This is Samsonic. So join us next time and connect with us in all social media platforms. Have a nice day.